So what they have here is a 5 ohm resistor. It's connected to a battery, and the current is 0.36 amps. And then the internal resistance we do not know. And then when you change the resistor from 5 to 4, the current is now different. It's 0.485 amps. So the question is basically, what is the internal resistance, and then what is the voltage of the battery? So we can actually use Kirchhoff's loop rule here. In the first case, the loop rule would say E minus 5 times 0.36 minus 0.364 equals 0. And in the second battery circuit, E minus 4 times 0.485 minus 0.485 or equals 0. Yep. Well, it has to be like this because this internal resistance is inside the battery. So these go together as one unit. So the resistor must be here to make the circuit complete, you know. Yes, I think. Oh, they're separate. Because it says a 5 resistors connected, and then when a 4 is connected. So this is the problem Louise had yesterday as well. I think you're also thinking they're on the same circuit, but because of the word when, it means it was changed. So maybe you want to circle that word then. Yeah, but it's okay. This is what you taught as well. The 4 and the 5 are together, but they get changed. So here, if I minus them, I get 0.14 plus 0.1254 equals 0. Uh-oh. I don't like that. It is minus now. Maybe I did something wrong. Uh-oh. It should not be minus. Maybe I misread something. Oh, Abraham, you're right. Thank you. I misread the question again. So sorry. I'm so sorry. So what happens here, this is terrible, absolutely terrible. Well, it's not so bad because I figured out something went wrong because my resistor was negative. Shouldn't be negative. If you use the loop rule here, you get E minus 0.36 times 5 minus 0.36 or equals 0. And then it says a 4 ohm is connected in parallel with the 5. So then they stick a 4 here. And then the current changes to 0.485. So I need to know what the new resistance is. 1 over R equals 1 over 5 plus 1 over 4. So that's 9 over 20. So the next circuit actually looks like this. And this is 20 over 9. And this is 0.485. So the loop here would be E minus 0.485 times 20 over 9 minus 0.485 or equals 0. So if I just write these two equations together, I have E minus 0.36 times 5 minus 0.36 times or, and then I have E minus 0.485 times 20 over 9 minus 0.485 or equals 0 equals 0. So I minus them. So here I get minus 13 over 18, and then here I get plus 0.125 or equals 0. So now I have my first answer, or equals 5.78 ohms. And that's the answer for the first part. If I put this answer back in here, I can then get the answer for the second part. E equals 0.365 plus 0.364. So then you get the voltage is 3.88 volts. And that's the answer for the second part. Well, I messed that up, sorry. But this should be okay now.